Eddie?
Um, I don't know. I think that was pretty
Pretty
quick, easy.
self-explanatory. Okay. Yeah, you can start on the homework. It's probably the same thing.
Yeah, I just may be asking lots of questions, but I'd rather get through the homework and do the quiz. Like I said, I just need to be gone by, get off with you guys at 1:30 today.
Okay.
And then if I have more questions, I can just rewatch the video and do all the prep with that guy.
Yeah.
I'm just getting a drink.
Right. Sweet. Um,
So wasn't that test like nice compared to the homework?
it was a piece of cake. It was so nice.
Did you get 100%, or do you feel comfortable saying?
No, I missed one. I was close.
Have you done it yet, Eddie?
Yeah, I missed a few, but I don't know. Some of the wording was like confusing me.
I missed a few. I got a B. I got 87.
Yeah, it's
Yeah,
good.
I got an 89, but I don't know if maybe the percentage ones I got wrong because it says put your answer without using a percentage,
Mm-hmm.
and so I don't know if they wanted like a point 80 or just an 80.
Oh, yeah, yeah. This
Well,
homework
you
is so
knew.
long.
This homework?
Yeah.
What? I thought it was only...
23 problems.
Oh, yeah. Yeah, yeah. I'm like, it's only 1.5 pages, but it's tons of
Yeah.
questions. All right, let's get going on it.
Let's do this.
Well, good for you, Catherine. I'm glad you did well. Good job, Eddie. I was thrown on the QQ plot. I don't know. Did you guys say it was normal or not normal?
I put not normal.
I put not normal. And so you got 100%?
No, I didn't get 100.
Oh.
I
Oh, you
got
got
an A.
one.
Yeah, I just got an A.
Yeah. Well, I put not normal too.
I don't know. I mean, I can see how it's normal, and I can see how it's... That was definitely not the best picture they could have chosen.
Dude, I like spent too much time on that one. Like, I looked like, oh,
Yeah, same here.
I was thinking, I don't know. But anyway,
All
I
right.
left that one to the end. I like actually came back to it because I wanted to think about it some more.
Yeah.
Let's get going.
Okay. All right, RE number 1. In your own words, explain what a p-value is. So, from the video, it says that the p-value is the probability that you get a result as extreme as your sample or hypothesis, something like that. Right? You get, okay. You get a value as extreme or more extreme than you saw in your sample if the null hypothesis is true. Right?
Yeah. Let's see. I'm just going into the homework. Let's see. Sorry, I only printed off the answer key. I'm going to look at the questions now. Okay. All right. Yeah, it says that it is the probability that you get a result as extreme or more extreme than the one you saw in the sample, if the null hypothesis is really true. I'm just going to print this out because I like writing down notes on it.
Mm-hmm.
And number 2, when a hypothesis test is conducted, which hypothesis is assumed to be true? That's the null hypothesis.
Mm-hmm. Okay. I'll read, or do you want to read
I
through
can.
one? Okay.
State the null and the alternative hypothesis that you would use to test your claim.
You have to read the little thing up above.
Wikipedia asserts that the mean height of males in the United States is 69.5 inches. Based on your experience, you suspect that the true mean height of males is less than the value. Use this information to answer question 3 through 5. Okay, so state the null and the alternative hypothesis that you would use to test your claim. Okay. So isn't the null just the 69.5?
Uh-huh.
Okay. And then the alternative hypothesis would be to use your test or claim. Well, I'm just looking at my notes here.
It would be
Thinking.
88 less than 69.5, right?
Yeah.
If it's less than or more than?
The mean will be less than 69.5. Yep. That U symbol means mean, right?
The U is yes.
Yeah.
The
Okay.
funky U. Yeah.
All right. Sweet. All right, so number 4. Is this a one-sided test or a two-sided test? Explain. I'd say it's a one-sided because it only wants the left side, which is a less than. Right?
Mm-hmm.
Okay. You want to read 5, Eddie?
Yeah. Suppose the sample data you collected had a mean height greater than the null hypothesis, and indicates that the null hypothesis should be rejected when, in fact, the null hypothesis should not be rejected. Was a type 1 or type 2 error committed in the Y?
Okay, suppose the data you collected had a mean or height greater than the one indicates that the null hypothesis should be rejected, when in fact the null hypothesis should not be rejected.
It's a type 1.
Okay, why is it a type 1, Catherine?
So, in the video, they set up this chart.
The rejector failed to reject?
Yeah, it's just like, let's see if I can draw it.
I did it. Like,
Okay. Let me click on you.
kind of see that?
Yeah. So you see where it says reject?
Yeah.
And then, so it says that it was rejected, so you know that it's a type 1. If it was not rejected, then it would be a type 2. Does that make sense?
That it was rejected, but it was still true. And so how do we, I'm just looking at this. In this question, what's the wording that tells us that it is still true but rejected?
Okay, so it says that the null hypothesis should be rejected when in fact the null hypothesis should not be rejected. So it says that it was rejected, and on the top it says that it should not have been rejected. The correct one was it not being rejected. I don't know how to explain it. But
okay, it should be rejected. So that means that they assumed that it was oh no. That's not assuming it's true.
No, it was rejected, but it should not have been rejected. So it's a type 1 error.
Okay. I'm going to have to grasp this concept a little bit more.
It's kind of hard to explain. The videos explain. Did you watch the videos?
The guy with the red hair.
There's a guy with red hair. I only watched the ones on the prep assignment.
I didn't watch the Brother Cromer ones.
Yeah,
Does
those
he explain
were good.
I just was going through the preparation assignment because the guy with the red hair goes through each question in the preparation assignment.
I don't watch those.
You get it without watching them, and that's great. I need to watch them with him and go through them.
Yeah,
I'll
if you
try
watch
Brother
the
Cromer.
videos, yeah,
I'll watch the Brother Cromer videos.
he's
Okay.
really good at explaining it.
Because I wasn't getting it from the redhead dude. So, I'm kind of grasping it. But my issue is then reading the information and being able to apply it into, if I'm thinking this graph out in my head, where does it go wrong?
Okay, well, hopefully in this next one you'll be able to figure it out.
All
I
right,
might just do the wording.
All right. According to Statistical Abstract of the United States, the mean consumption of fruits per person in 2003 was 98.4 pounds. A dietitian believes people are becoming more health conscious and that fruit consumption has increased since then. Use this information to answer the question 6 to 10. Okay, determine the null and the alternative hypothesis. Okay, so the null was the 98.
Uh-huh.
That's the null. Okay, and then the alternatives. Oh, is the let's see. Oh, it's just if it's above or below, right? Or equal to.
Yeah, so if it's greater than, then that means that the mean is greater than 98.4.
And we just put the greater than and the smaller than, or the equal to. The only two that are alternatives are the greater than and smaller than, right?
No, if it's different, then it's just not equal. It's like the equal sign with the line across it.
Yeah.
Yeah. So. Yeah, the null hypothesis is always going to be the same from what I can see, but the only one that changes the alternative depending on the wording of the question.
Okay, and so just depending on the wording, because in the notes or the guy that I watched, like he was just saying the alternatives are always if it's going to be greater than or less than. So like in this question, we just need to find if they're asking if the alternative is greater than or less than. Is that
yes.
kind of the idea?
Then the mean. Yeah, then the mean.
Then the mean. And so this one is, let's see, greater than?
Yeah, the mean is greater than the 98.4. Does that make sense, kind of?
Well, I know that rule, that it's just one of those. I don't understand why or anything, but just what he was saying is that it's either greater than or smaller than, and it just depends on the question and what they're stating it is, and then that's the alternative.
Mm-hmm.
Okay.
Yeah, I'll read 7.
Yep.
Is this a one-sided test or a two-sided test? Explain. So I would say that it's a one-sided.
Hi, Donna.
Hello. What number are we on?
7.
7.
Okay.
Of the homework.
Oh, of the whole, not of the.
We're not doing the prep right now.
Okay.
Yeah, because the homework's the same as the prep, basically.
It is? Okay, let me pull up.
Well, not the same questions, but same concepts.
It's the same but different.
Yeah.
Okay. One-sided or two-sided?
So I would say it's one-sided because it's greater than, and it's a right side.
One-sided, with the tail going to the right?
Yes. Or the, yeah.
So basically, whenever it has one of the alternatives, if it's greater than or less than, the guy I listened to was saying that those alternatives are the one-sided.
Mm-hmm. The only two-sided test is when it says different than.
Or not equals to.
Or not
equal
yeah.
to.
Mm-hmm.
Got it. I did get that far in the notes.
Okay.
Okay.
Okay, so for number 7, you got one-sided.
Mm-hmm.
Okay.
You get this chapter pretty good, Donna?
I think so. It's just a lot. It's not really a lot of math. It's just a lot of other stuff.
Yeah.
Yeah.
Okay.
8. What would be the considered type 2 error in this example?
So if it said and the fruit consumption is different than 98.4, then it would be, or not equal to, or something like that. It would be type 2 error.
Is that failing? Failing to reject? No.
The answer to this question is a lot more complicated.
Then what number 8.
How do we know that though?
It's a good question.
What would be considered a type 2 error in this example? Well, the type 1 error would be if we reject the truth. So type 1 error is if we reject 98.4, right?
Mm-hmm.
So a type 2 error would be the opposite. So
Be to
Failing to reject.
Not the one it is.
Okay, so reject. Oh, you're right, Donna. Type 2 error means don't reject the null hypothesis, but the alternative is true. And then a type 1 error is you reject the null hypothesis, and the null hypothesis is true.
So I don't know if you watched the video, but he said the type 1 error always rejects the truth.
Mm-hmm. Did you watch the Brother Cromer videos?
I watched all the videos. I watched the 2 that you don't see. Who's the guy that actually stands in front of the chalkboard?
The redhead guy. I don't know his name.
Yeah, I watched that one, and I watched the other ones. The audio on the other ones is kind of horrible.
Yeah, I just watched the audio ones. That's basically all I watch.
The video one was where the guys at the chalkboard was kind of helpful.
Okay. But yeah, I can see. Do you get that, Eddie?
Okay, so just failing to reject the null hypothesis when the alternative is not true.
So the definitions for them is, so type 1 error is when you reject the null hypothesis, but the null hypothesis is true. And then a type 2 error is when you don't reject the null hypothesis, and the alternative is true. So they're just like opposites.
Oh, Donna's typing.
I was like,
what is that rubbling? You're a fast typer, Donna.
I am a fast typer.
that's so nice. You can type all my essays.
I talk into my phone too much these days. Emails, everything.
That's nice.
Okay. All right, let's go on to 9.
Okay.
Okay, I'll read it. If we tested the hypothesis at, what is that one called? Alpha, right?
Alpha. Mm-hmm.
Equal to 0.01 level, what is the probability of committing the type 1 error? Explain your answer. That was in our work lesson, I think.
So when the probability goes up, then the other goes down.
What is?
Let's see. If we tested a hypothesis at 0.01 level, what is the probability of committing a type 1 error? So the probability of committing a type 1 error, isn't that?
It's like 0.01. It's 1% is what it is.
I think it's just 0.01 because alpha is a type 1 error. And so the probability of a type 1 error of occurring is that it's just 0.01.
Oh, makes sense.
Right?
Yeah.
That's what the answer says.
What's the answer say?
Just what Catherine said. That a type 1 error is an alpha or a 1 or 0.01.
Okay.
Yeah, and if it said beta, then that would be a different answer. But since type 1 is alpha and type 2 is beta, the answer is 0.01.
Wait, type 2 is beta?
Type 2 is beta, yeah.
Oh.
He didn't really explain beta. All he said is that when one probability goes up, the other goes down.
Yeah, to get the error 2, you have to have your alpha, well, the probability has to go up, right?
Yes.
I had this all written down and I don't know where I put it. I like ran out the door. Okay. So in your in what is this? The not the homework, but the other lesson that we have. It says the same thing in number 9, part C. It says if the analysis was done at alpha equal 0.01 level, what is the probability of committing a type 1 error? And it's 1 in 100 or 1% that there would be a type 1 error.
On the prep assignment?
Yeah.
Let's see. Can you read the question again?
Number 9, C, it says if the analysis was done at alpha equals 0.01, what is the probability of committing a type 1 error? And it says it's 1 in 100 or 1% that there would be a type 1 error.
Mm-hmm. The same thing as alpha equals.
Because if you look,
Oh,
if you
yeah.
look 0.01, it's you have 1 in 100 chance of making an error.
Yeah, so 1% would also be right for this question then. Yeah. I was thinking that 1% was 0.1, but that's 10%. So, yeah. 1% would be right too, I think.
Mm-hmm.
So then the next one says if we want to decrease the probability of making a type 1 error, we would need to increase or decrease the level of significance. And that means we need to increase it, right? No.
No, we need to decrease.
Decrease it. No, a type 2 would be increasing. Yeah. So it would be like a point, oh, well. Yeah, if we wanted to decrease the probability of making a type 2 error, we would need to increase or decrease, yeah. If we wanted to decrease the probability of making a type 2 error, we would increase it.
Yeah.
Is that because if we get lower than the 0.01?
Because if we want it to be over, like, to accept the hypothesis, it has to be under, what was the null hypothesis?
So, for it to be accepted, it has to be either as at the level of significance or greater than the level of significance, right? Or like more extreme. Is that what you're talking about?
Yeah, because it has to be, like, you choose the level of significance, so, right? Like, if you want it to be 0.01 or 0.05 or 0.1, if your probability is, say you had you wanted it to be 0.1 or not above, if you got 0.105, then you have a type 2 error because you can't accept that the null hypothesis is rejected.
Not rejected. Type 2 is when you don't reject, and then type 1 is when you reject.
When you reject the truth.
When you reject the null, but the null is true.
If we reject the null, then the alpha would be, for example, for this one, 0.01. Then if we reject it still, it'll be below that, right? So 0.0001.
That's a really good question. I don't know.
So if the P is low, you reject the null. So like if you had, sorry, I said it wrong. If you had 0.0 or .1 and you got .09, then you have to reject the null.
Yeah.
Okay.
Mm-hmm.
But if it's above the .1, like a .2, then you accept the null, right?
Right.
Yeah.
Because it's above.
Well,
So
he said you don't ever accept a null, you just do not reject it.
It's either reject or fail to reject.
Yeah.
You never use the word accept for some reason.
Yeah, but they said that, and then in the chart they put correct decision. So I guess it's a correct decision also.
Mm-hmm.
Okay.
Okay.
We are on 11.
Yeah.
Okay.
I'll read. Or
You
go
can read it. Go for it.
A simple random sample of 100 two-month-old babies is obtained. The main head circumstance is found to be 40 centimeters. Assuming that the population standard deviation is known to be 1.6 centimeters, use the alpha 0.05 level of significance to test the claim that the mean head circumstance of a 2-month-old baby is not equal to the 31.4 centimeters. Use this information to answer questions 1 through 16.
Okay.
So, well, the null is the original number.
So 40
The
centimeters?
40. Yeah.
Okay. The alternative is head is not equal.
Not.
So it would be not equal to 40 centimeters.
Yeah. Because it's at not equal 39.
Yeah.
And that's the sign, the equal with the thing through it. Okay, use this, and then,
Okay.
and
So,
that's,
yeah.
that's the alternative.
Mm-hmm. Number 12 says, compute the sample test statistic for this analysis. So this is where we just find the z-score, right?
Yeah.
Okay.
Is this using that newer z-score
Yeah.
thing?
It's where you use the 39.4 minus the mean.
The sample means minus the population mean over the standard deviation divided by the square root of the sample size.
Great.
Yes. Uh-huh.
Okay.
Do they give us a sample size? Oh, 100, yeah. Cool.
Okay. What are the numbers you guys, let's see, the sample means is
Okay, I got negative 3.75 for the z-score. Did you guys get that?
Hold on.
Negative 3.75?
Yeah,
What did you get? Negative.
3.75 for the z-score.
Okay. Oh, I added an extra 0. Yes, 3.75.
Okay.
can you, I know you all know this. What did you guys, how'd you know the sample means, the population mean? The population,
The mean of the
Is
head
the-
circumference is the 40 centimeters, but
that's
Your-
the sample mean?
It just says the simple. It has to be simple random sample, by the way, but it says a simple random sample of 100 2-month-old babies.
Mm-hmm.
Oh, but you're talking about the sample mean. That's just the 39.4.
yeah, 39.4, and then the population mean is a 40.
The 40. And then you did the standard deviation is the 1.6 divided by the square root of the
Simple
the
random sample
simple
size.
random sample size, which
Mhm.
is the
100.
100.
Yeah.
because that's the sample size. All right, thank you. I'll go back over and look, make sure I'm able to find all those.
Okay. Then we just have to open up the applet for the next one, I think.
Yeah.
Okay. The sample test statistical analysis. Okay. What did you guys get? I got a different answer than. Oh, actually, no, I got the right answer. Just kidding.
Let me open the applet.
I just got into it. All right. I didn't do the whole problem. What was the Z-score you got, Catherine, or anybody?
The Z-score I got was negative 3.75.
3.75 negative.
Yeah.
Yeah.
Okay. And then are we looking for greater than or?
No, we're looking for both of the right and left. So you click on both of the sides.
How do you even click on that?
So if you go to a smaller one and make sure you highlight the two sides, by the time you do the bigger one, it's already highlighted for you.
Well, did you get the 8.8? Let me see what the answer is.
You get 1.176 times e to the negative 4, so it's 0.00018.
And they had it in the lesson written as 1.76 times 10 to the fourth power.
Mm-hmm.
Negative fourth power.
Negative fourth power.
Yeah.
Yep.
So on the area, mine was like 1.6. I'm sorry, 1.768. Do we not round that, or is that what you got, or no?
Yeah, I got that. So once you move the decimal over 4 spots to the left, you get 0.000176.
Mm-hmm.
And then you round the 7, so you get 0.00018. It's just practically the same answer.
So what did the answer in the answer key give you?
It says 0.00018, but they also give us the picture that we have, and it says in the area in the picture that it's 1.76 e to the negative 4.
Okay.
So they just rounded their answer.
Okay.
Yeah.
I just don't know how they want us to answer that, because there's a lot of different ways to write that out.
Spread it out.
See, and for 14 it says, label the sample test statistic and shade the p-value on the sampling distribution curve. So that's basically what we did. You just choose both sides.
Okay.
All right. Read 15. What decision do you make based on the p-value and the level of significance of alpha? So I would reject the null hypothesis.
Yeah, because it's low,
It's
right?
so low.
Yeah. And what else is, and the level of significance of alpha. So you reject the null, and the p-value is less than the level of significance. Or do you just say, just reject the null? What does the answer say?
Reject. Just reject the null.
Okay. Cool.
State your conclusion in an English sentence.
Wow.
If you're from like Cambodia, I just can't imagine. Okay. Let's see.
So we would say, because it's so low and it rejects the null hypothesis, the there is enough evidence to show that it's different than the null hypothesis?
I would say you're good on that.
Yeah, it's different than, very different from what the other babies are, the 4D.
Sweet.
Okay, 17 or 18?
We haven't started 17 yet, so you just have to read all of those paragraphs.
Yeah.
Okay, I'll read. Because of the increased demand for corn for food, animal feed, and ethanol, the USDA is trying to determine if corn production is keeping up with demand. They have determined that a yield of at least 135 bushels per acre will be necessary to meet the demands for the coming year. If the yield is less than 135 bushels per acre, then the USDA will need to recommend an approach to ration corn for the next year. The mean yield of corn in the United States is about 135 bushels per acre. A survey of 50 farmers this year gives a sample mean yield of 133.1 bushels per acre. We want to know whether this is good evidence that the national mean this year is decreased 135 bushels per acre. Assume that the farmers surveyed are an SRS from the population of the commercial corn growers, and the standard deviation from the yield of the population is 10 bushels per acre. Test the claim that alpha 0.05 level of significance. Use the information to answer questions 17 through 23. That's a lot of information.
It is.
I'm trying to. I always like to circle what I think is actually going to be applicable to.
Corn production.
The
The mean would be 135.
Which is also the null.
Yes, that's also the null. And it wants to decrease or less than, right?
decrease. Yeah.
So if it is less than, then that means the mean is less than 135. Right?
So that's an alternative if it asks for what the alternative is.
Yeah, for number 7.
Less than 135?
Yeah, because it's less than the null. The state the null alternatives. Compute the sample test statistic for the analysis.
So we have to find the z-score for this one.
So it's 133.1 minus 135 over, where is,
I think it's 10. Yeah. 10 over the square root of 50?
is it?
Yeah.
Where's the 50? The point? No, up there. The survey.
Survey.
Yeah.
Got it. Is the sample. All right. I'll actually do it.
Okay. So I got a z-score of negative 1.344.
Yep.
Okay.
Hold on just a second.
I got it too. Okay.
And what was the answer? I'm sorry, negative 1.344?
Yeah.
Yeah.
All right.
Determine the p-value, so we have to plug it into the applet. And it's just the left side, I believe, right?
Because it's decreased. It's everything below.
Yeah.
That's what I think.
So it's negative
1.344. 0.0895.
Yep.
Oh, wait. 15. Oh, that's why they just put the 0.9, the 0.9 in the
Yeah, they
answer
just
key.
rounded up.
Okay. We just answered like all those ones through
The
19.
Yeah. So number 20 says label the samples test statistic and shade the p-value on the sampling distribution curve, which we already did. What decision do you make based on the p-value and the level of significance? So the p-value is 0.09 and the level of significance is 0.05. So you accept or you do not reject the null?
Right.
Yeah.
Failed to reject? Is that
Yeah.
the wording they use?
Mm-hmm.
Yeah.
Okay. So, yeah.
Let's see, that was
That
21.
was 21.
I think I just need to get in a practice of where to plug things in, because if I can see that graph in my head and just kind of be like, it was true, but it was rejected, or, depending on the wording.
Yeah.
Okay, state your conclusion in an English sentence.
So it would be like there's insufficient evidence to say that the
To support the null hypothesis.
insufficient to say that less than 165 bushels are necessary to meet the demands, right? Something like that.
Yeah.
Yeah.
Okay. All right.
Let's go in, if you guys are okay. I'd love to be here for as much as the quiz as possible. And then I need to leave at least by 1:40 to get over to my kids' school. So if we don't finish, if one of you guys can just email me the rest of the scores, I'd appreciate it. But we'll just see how long the quiz is.
All right. Group quiz, right?
Yeah.
Okay. It should be pretty quick, right?
It seems like, yeah, hopefully they just have multiple choice, choose this for this explanation. Like, they're not going to make us type in what the actual, wording, when they were saying describe in a sentence.
Mm-hmm. Yeah, probably not. They'll probably have it written down.
Lesson 9 group meeting quiz.
Okay. All right, so question 3. Are you guys all ready?
Yeah.
Just clicking that I'm here.
Okay.
Which hypothesis involves equality?
That is the null, right?
Yep.
Yeah.
The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Remember, the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually obtained.
When computing the p-value, which hypothesis do you assume? P-value is probably...
It's a null.
You assume the null hypothesis is true.
Yeah. Okay.
If it's more extreme, it's alternative.
Yeah.
It's greater than or less than?
If it's less than the level of significance, don't we...
More than the level of significance.
Yeah, you're right. Okay.
So it's the null.
It is the null, yeah.
Okay, 5. Suppose the null, 10, use that. Which of the following represents the alternative hypothesis to the tell?
It's the not equal one.
Mm-hmm.
It's the two-sided one.
Yeah.
Yep.
Left one is when...
Wait a minute, is it
The equal sign with the slash through it is the not equal, and that's one that's the two-tailed test.
Represents two-tailed. Okay.
The left-sided would be...
The mean is less than the 10.
Yep.
Okay.
Wait. sorry, you guys. So I just did 5 was the equal with the slash through it.
So
Uh-huh.
C, like
So-
A, B, that'd be C, and then
What did you
6
say? 6?
I said
The
C.
left sided.
Yeah.
6 is, the mean is less than the 10.
Or
Okay.
A.
A,
So
yeah.
A, yeah.
Okay, yeah.
The less. And then the other one, right sided, would be the B,
Yeah.
Uh-huh.
the more greater than.
Mm-hmm.
8. Let's see.
Remember that we determine the outcome of a hypothesis test by computing the p-value to the level of significance, or alpha. Use information to answer the next 2 questions. Which relationship would result in failing to reject the null hypothesis?
The P is greater than alpha, right?
The p is, yeah, greater than alpha.
A.
Yeah.
Think so.
And
Yeah.
which relationship would result in rejecting the null hypothesis?
B.
What?
B.
Failing.
I don't know. What do you guys think?
Which relationship would result in rejecting? That's when A is smaller than alpha, right?
So B.
Yeah.
Yeah. It says, oh yeah, yeah. No, B says that the p-value, A is greater than the p-value.
Oh, yeah, right.
So isn't it
A.
p-value? Failing to reject is,
B
and
less
then
than the
rejecting.
alpha.
So when the p-value is greater than alpha, would be when we reject the null. So alpha has to be greater than the p-value for number 9, right?
Number 9 is B.
Yes, number 9
Because
is B
less
because
than
Okay.
alpha.
All right.
8 was A. 9 was B.
Mm-hmm.
10. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this information for the next 2 questions.
So which of the following would be the appropriate alternative hypothesis? So it's greater than. So that means that the mean is greater than 1,500.
so the
So
average
C.
claim amount is greater than 1,500 C, yeah.
Yeah.
Okay.
Which of the following would be the appropriate null hypothesis? The null hypothesis would be
Just
the 1,500.
equal. Yeah.
the
average-
equal to
Yeah.
A.
Mm-hmm.
Okay.
All right, the next one. The
Okay.
insurance company randomly selects 40 claims and calculates a sample mean of 1650. Uses information to answer the next 3 questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
Yes. Because the population sample is large.
That's
Yeah,
right.
because it's over the 30. So A.
Mm-hmm. So I think it's the central limit theorem for the next question.
What theorem or law justifies the answer? Sounds good.
I don't remember what the definition is for that, but I remember him saying central limit theorem in the video. I didn't hear any law of large numbers.
No.
Let's go with that for right now.
Which of the following is the test statistic as defined in this lesson? Test statistic.
So x with the line over. So
X
z
bar?
is for x bar.
Is it the X
And-
bar or the S?
The n.
I know it's not the Z. I know it's not the N.
Is it? X bar is the.
That's the.
The X bar is the sample mean. A
Sample.
sample mean is 1650.
So
So,
which is the test
And,
which of
N
the
is the
following-
sample size.
yeah. And Z is the Z
This is the-
score.
So it has to be S.
Okay, let's try that.
I don't remember seeing any S's, but
Me either.
Yeah, I don't either.
Which of the following is a test statistic as defined in this lesson.
Okay, well, no, the test statistic would be X bar.
I think so
Yeah,
too.
Because that's the sample mean, because that's what we're testing against.
Yeah, that's what we're testing. That's the test statistic.
Yeah, I think it's X bar.
Okay,
Let's
X
go with
bar.
that.
Yeah, because I didn't see S anywhere.
Yeah, I don't remember seeing S.
Me neither. Okay, the historical mean of sales receipts at the grocery store is $150 with the student deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with this, She will use the level of significance of that. She then takes a simple random sample of 36 sales receipts. Do you think we need to just put together a z-score?
Yeah, that's the question asked for.
So let's do that.
It'd be
144 minus 150.
Yes, 144 minus 150
Where's the
over
standard? Where's standard deviation?
40.
40.
40 divided by,
The square root of
what's the sample?
36.
36.
Yeah.
Oh no, mine's giving me a fraction again.
It's. Did you guys get negative 0.9?
I'm getting there.
Oh, that would be, because I'm getting a fraction of negative 9 over 10. It's so annoying! My calculator. Okay, but that's the same thing.
Yeah.
What did you get?
I got
One.
negative 0.9.
I didn't get that. Hold on.
Let me.
So it's 40 divided by the square root of 36. Oh, well.
Oh, there, I clicked this extra button I learned of, and yeah, I got the decimal now.
All right.
And 0.9, yeah.
Negative
Yeah.
0.9.
Yeah, negative 0.9. Okay, what is the p-value associated with the z-score? Oh,
So it says decrease, so we click on the left.
okay. And we got a negative. Let's add it up. The
0.184.
0.184.
Hold on just a second. I don't know. My applet just disappeared. I want to make sure I'm doing it right.
Okay.
Oh, hold on.
0.184.
Okay, I got it.
Okay.
0.184. All right.
The inference would make you would you make about the null hypothesis for this problem?
The null hypothesis, or the alpha, was 0.05, so it's bigger than 0.05.
So you do not fail to reject the null hypothesis.
I fail to reject it.
Yeah.
Yeah. What is your conclusion for this problem? There is insufficient evidence that the true population mean is less than 150.
There we have. Is that C? We have insufficient.
Yeah, thinking
evidence?
C.
There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null when the null hypothesis is true?
Type 1.
That is type 1. Okay. 20.
Researchers decided that instead of using a level of significance of alpha 1.05, he will use an alpha of 1.01, or 0.01, and the following to be true. Probability type 1 error increase.
So the probability of a type 2 error will increase. Because if you lower one, if one of them goes down, the other one goes up, and vice versa.
Get teeter-totter. All right. If alpha is that, compute the probability of committing a type 1 error. Round to the nearest thing. Let's see. What do you do for that?
It's 5%.
Is it just 5%?
So it's just 0.05, right?
Is it just that?
Yeah.
You don't put in round. Oh, it is 0.05,
It
but
says round to 2 decimal
Yeah.
places. Yeah.
okay.
All right. I'll submit it first, just to
Okay.
see.
I want to go through the answers because we went through that really fast. So go ahead and submit it, and then I want to go through them before we
Okay.
all put it in.
We missed one.
Which one?
Question 14.
Okay, let's go to 14. 14 was, which of the following is the test statistic as defined in this lesson? Oh, that was the one. So it's not X bar. Should we try S?
Yeah, someone try S.
Yeah. I'll go for it.
It's N,
You think it's N?
maybe.
Oh, my thing isn't. Oh, here. Well, I'll try it.
I
Okay.
still remember S.
Yeah, because they never talk about S, so.
Which one did you choose, S or N?
Oh, I have 9 wrong for some reason.
See, that's why I wanted to go through the answers because we were going through them so fast. Okay,
No,
let's go.
no, just a second. Let me check 14 again.
Okay.
What did we get that one? 14. Yeah, that one's wrong also.
What did you put?
S.
Okay, so it's N. Okay. Okay, let's go through the answers really quick before I don't want to make another wrong one.
Mm-hmm.
Okay, so for number 3, I got A, the null hypothesis.
Mm-hmm.
Number 4, or question 4, I got a null hypothesis.
Just a second. While you're going, I want to do it again. So let me type in the same answers.
Okay, that's fine.
Eddie, you still have all the answers, right?
I do too, so me and Eddie can still
Okay.
submit them.
Okay.
Go ahead then.
Okay, so A, Eddie, you can go through this with me too. So A, null hypothesis for 3. For number 4 is the null hypothesis. Number 5 is C.
Yep,
Yep.
Number 6 is A.
yep,
Number 7 is B.
yep.
Mm-hmm.
Number 8 is A.
Uh-huh,
Mm-hmm.
Number 9 is B.
uh-huh.
Number 10 is C.
Yep,
11 is A.
yep.
12 is A.
Mm-hmm,
13 is B.
mm-hmm.
Mm-hmm.
14 is D.
Yep,
15 is negative 0.9.
uh-huh,
16 is 0.184.
uh-huh,
17 is B.
uh-huh,
Mm-hmm.
18 is C.
uh-huh.
19 is A.
Yep,
20 is B.
mm-hmm.
21 is 0.05.
Yep.
Okay, I'm going to submit it.
All right.
We'll see. We missed one.
Which one was it this time?
Number 14, so it has to be S or Z.
Well,
Well, we already did S.
so it's Z.
We did S? I thought we did X bar.
We
Last
did
time-
X bar, S, and we did N.
Okay, so now let's go. Let me see.
Do you want to submit, Eddie, clicking
Yeah.
Z? Okay.
Oops.
And then someone
I
go
need to go
through the answers with me.
Yes, I want to go through it again too. Oh, that's not the one I wanted.
All right, let's just wait for Eddie to see if.
Group meeting quiz.
Andrea.
Okay.
Okay.
Let
Oh
me
my
hold on.
gosh.
Let me pull up the quiz. That was a
I guess we'll all look up that one.
yeah. Did you see S in there anywhere?
No. Well, it was the
But
answer
it's
was
Z. It is Z, but I'm like the S one we should have known because I didn't even see an S in there. The only thing new introduced was the alpha. I
All
thought.
right, let's go through these because I've got to get going.
Okay.
Okay.
So
So
1 and 2 are fine. 3,
Hold on. Let's go through because I don't have them again. So 1 and 2 are both null, right?
no,
Uh,
we're on question 3.
true and true. We're
Oh,
on-
okay.
So
3.
A,
Yeah.
Null hypothesis.
yeah. C,
That's for 5.
that's for 5, yeah.
Well, sorry, I missed 2 or question 4. Question 3 was the null.
Yeah, question 4 was the null. Question 5 was C, the equal sign with the line across it. 7 or 6 is A, less than. 7 is B, greater than.
Wait a minute. I just did 7. So 6 was the A. 7 was the B.
Was B, yeah.
Okay.
8 is A.
Got it.
9 is B. 9 is B.
Mm-hmm.
10 is C.
Okay.
11 is A.
Okay.
12 is A.
Mm-hmm. 13.
13 is B. 14 is B.
Okay.
15 is negative 0.9.
Okay. And what was 16?
0.184.
0.184.
17 is B.
Okay.
18 is C.
Okay.
19 is A. 20 is B. 21 is 0.05.
Okay. All right, Eddie, you already got 100%, huh?
Yep.
I'm going for it again.
All right, 100%, guys. It's good.
All right, thanks, everyone.
Yeah. All right.
All right.
We'll see you guys
Thanks.
next week.
Thanks.
Bye.
Bye.
Bye.